Hi everyone, Happy New Year and welcome to the Art of the Possible series. I'm Nehali Neogi and I'm a Principal Cloud Solution Architect at Microsoft. Today I'm joined by my amazing colleague Adam, who is a global black belt focused on Azure networking. Adam, I've truly enjoyed working with you on the efforts leading up to today's session. I appreciate your energy that you bring every day and welcome.
Thank you, Nahali. Likewise, I'm happy to be here and I'm happy New Year to everyone today.
Thanks, Adam. So today, Adam and I are going to share a real customer scenario. We will start by reviewing the Azure official documentation. Then we will review the architecture and problem statement using Draw.io, followed by an awesome demo that Adam has prepared and some troubleshooting tips. What you see on my screen is the official Azure documentation securing traffic to private endpoints in Azure Virtual WAN. So there are two types of network rules when it comes to securing the traffic in virtual WAN using the native firewall. There is network rules and then there is application rules. Today we will be focused mostly on the network rules. However, there is very little difference between network and application rules, and I'll call out the differences. As you can see, there are quite a few moving parts here. There are implications with DNS settings and FQDN, also how the firewall does the SNAT. So we'll be going over all of this in our design session followed by the demo. And with application rules, you absolutely need the DNS set up correctly. And the last point that I want to bring here is the concept of network policies, and that's something we need to support securing traffic to the private endpoint. There's some troubleshooting tips over here. We will be doing those as well. And that's it from the Azure Firewall documentation, going back to Draw.io. So what you see on my screen is a multi-region vWAN architecture with routing intent. This icon, if you've been following along with us on the vWAN series, this icon shows the routing intent is enabled. And if I show you here what it looks like in the portal when you have routing intent enabled, you could enable it for internet traffic going through the firewall and also for private traffic going through the firewall. In this particular case, we're using the Azure native firewall, but we will be doing sessions on using a third-party integrated NVA as well. So with that, with routing intent enabled, the private traffic, so spoke to spoke, will be going through the firewall, and of course the branch to spoke will also be going through the firewall. And with internet enabled, you will have all the internet bound traffic funneling through this firewall. So with that, let's dive into the scenario for today, which is, imagine that we have this vWAN architecture and the customer has a PaaS service. So that could be a storage account or a SQL server. In our demo, we're going to be using the storage account. And so the first thing you need to do is you need to project those private endpoints. In this case, we're projecting it to a separate VNet, and we've created a subnet within. That's where the private endpoints will get projected. And the flow of interest for this session is this. So traffic will be initiated from an express route connected branch and hitting this private endpoint through the firewall. That's the flow of interest. We want to secure it through the firewall. That is the flow of interest. For this flow to work, like I mentioned in the documentation, there are few different things to keep in mind. So let's start DNS first. Anytime you have private endpoints, you always have behind the scene a private DNS zone that gets configured with corresponding VNet links to all of this VNet, right? So for the DNS flows to work correctly, so in other words, for this VM on-prem to resolve this FQDN for the storage endpoint, the DNS has to be set up correctly end to end. We've done separate videos on hybrid DNS, but at a high level, the DNS flows would look something like this. So let's walk through it end to end, how the DNS flow would work so that this VM can resolve the storage account. So imagine the local VM would consult the local DNS server, and that DNS server will in turn do conditional forwarding to a DNS. In this case, it's an IaaS-based DNS server. And that DNS server would then consult the Azure DNS server 168.63 IP, and which will in turn resolve this private IP 172.16 251.4 as shown over here. Again, remember that we've done deep dive videos on hybrid DNS. Of course, we're using an IaaS-based DNS, but the best practice would be to be using the PaaS, the private DNS resolver, which is the Azure's PaaS service. So that's the DNS piece that needs to be set up correctly. And we can also use this Azure Firewall as a DNS proxy in this case, because that IP will be routable from on-prem. Anything, Adam, you want to add about the DNS resolution here?
No, I think I'm good, Nahali. You covered it pretty well in depth. So
Awesome. Yes, so let me hide the DNS setup for now, and let's move on to another concept that we have here, which is the SNAT. So out of the box, when you set up the Azure Firewall, and I have a screen capture here to show you this, any traffic that goes between RFC 1918 addresses, in other words, traffic going from this VM to this private endpoint, or even on-prem to this private endpoint, that traffic will not be netted, right? So you have a checkbox over here to bypass to not perform SNAT for RFC 1918. Of course, you can change this behavior depending on whether your PaaS service requires SNAT. So just keep that in mind. For both of the services that we tested with over here, we are not netting the traffic. Okay, so that's that. Anything else, Adam, on the SNAT bits?
I think I'm good, Nahali.
Okay, awesome. So that's the SNAT. And now let's talk about the root issue for this particular scenario. Again, the flow of interest is traffic initiated from this VM to the private endpoint. What happens is that when we initiate the traffic going in this direction hits in this direction from on-prem to the private endpoint, bypasses the firewall, and then the return traffic hits the firewall, the flow gets asymmetric, and that traffic breaks. Again, this assumes that the DNS and everything is set up correctly. This is strictly the routing setting. So now the solution for this is to enable this on this particular private endpoint subnet, and we need to enable what's called the network policy for private endpoints. And there's a checkbox for route table over here. Essentially what it does is there is a /32 that gets injected for this private endpoint, which causes the asymmetric routing. And with this toggle, the traffic flow will work. And Adam is going to show you all of this in his demo. And there is one more layer of security. Today's topic being securing the private endpoint. In the event that you want to secure, in addition to the firewall, you can also secure this private endpoint using the Azure native NSGs. And so that is the toggle right over here. Anything else, Adam?
No, I think it's good, Nahali. And yeah, to Nahali's point as well, the reason you initially get that bypass because the /32 is more specific, but then since we're using routing intent, the return traffic knows it needs to go to the firewall. So we're basically fixing that behavior with that toggle, as Nahali mentioned.
Precisely. Great call out, Adam. Yeah, so let me just go through my notes over here to make sure we have covered all of the points. Yep. And yes, so one more thing before I hand it over to Adam. This is what our lab's going to look like. This green flow, again, is the flow of interest. We have a simulated branch, an express route connected branch, which is GCP. And we have a VM in the simulated branch, which is going to initiate the traffic first to the VM in Azure, and then we will test it to the private endpoint. Okay, in our case, both the private endpoint and the VM are in the same VNet. We also have, we're using again storage as a PaaS service, and that storage is projected as a private endpoint in this VM. So most of our tests we will be running from this VM to the VM in Azure and the private endpoint. Anything else about the lab, Adam, that you want to share?
No, I think that looks good. Thanks, Nahali.
Awesome. Then over to you for the demo.
Okay, thanks, Nahali. Let me go ahead and share my screen and I'll go ahead and kind of walk through the lab and do like a little bit of housekeeping. So, all right, hope you guys can see my screen. Okay, so to kind of start through the simple lab, I'm kind of just showing the GCP end first. I won't go into a ton of depth in this, but as you guys can see, I have the VLAN set up on GCP. So this is sort of GCP's equivalent of express route. You can see here I'm using Megaport as a provider. So this is our branch connection that Nahali and I are using to simulate the test, right, to our spoke VNet, which is connected to the vHub. So I'll just kind of step through this really quick. And here's our GCP NIC, right, our GCP VM that we're going to be running the test from to Azure. So that's that 10.408. So pretty simple. But I also wanted to show a few more housekeeping stuff, like as far as I want to show like that routing intent's enabled in the storage account side. So let me go ahead and switch gears and I'll go over to Azure here. So this open spoke VM is our spoke VM that's sitting off our VNet hub that's peer to our hub. Also in the same VNet as where our PE lives, or our private endpoint. So our private endpoint is in the same spoke that our VM is that we're going to be doing test to. That's the 10.304. And then to kind of show you guys, right, like how routing intent's enabled, and I'll show you that screen as well. But let's go ahead and take a look at the networking of this VM. So let me go up here to networking settings because I want to show you guys the effective routes of the NIC, right? And we can also see that /32 for the private endpoint. So let's go down here. We'll go down to effective routes. Wait for this to come up. Takes a little bit of time. Okay, cool. So we can see here that the first couple of pairings we can kind of ignore. Those are just some other pairings. But you guys can see here, We know that Nahali and I have enabled routing intent because it injects both the private, if you have private enabled, and then also if you have internet enabled, it does the 0, right? And this next hop over here, this is the firewall, what we call CA address or internal address. So we're saying, oh, anything private, send to the firewall CA, anything destined to the internet, send to the firewall CA. And you guys will also notice down here that we also have our private endpoint enabled, right? And that's that /32 for the interface endpoint. So we know that this VM has that enabled, right? That we're going to be testing to. So to kind of do a little bit, step through a little bit more, I wanted to show you guys the storage account. So here's the storage account that Nahali and I have enabled that we're just doing our simple PAS test to. So you see over here in private endpoints, we have our storage account private endpoint. We have, obviously that'll be a link to that blob.core.windows.net when we test to that PAS FQDN. But for simple purposes, we're just kind of leaving this storage account, open, and we're not doing anything crazy on it. And then to show the private DNS zone, which of course has to be linked to when you create a private endpoint. So this is the private DNS zone. This is, of course, our private link.blob.core.windows.net. It would be for the same thing for any other PAS service, just a different PAS naming convention on the end. And we can obviously see that our spoke VNet is linked right to that private DNS zone. And we need this in order to facilitate the name resolution, right? So that's kind of at a high level, just like stepping through. Like I said, the diagram is a very simple diagram that Holly had showed earlier. Basically, you have GCP connecting to our secured hub, and off that secured hub, we just have a spoke that's VNet peer to the secured hub that happens to have both the private endpoint and the VM NIC. I think, Holly, I covered everything. Did you want to? I'm not sure if I missed anything before we start to go to the test. If you want to add any commentary.
Yeah, no, you covered most of it. Just couple more things. One thing I was thinking, Adam, maybe just show the public and private networking with routing intent and how we are steering it through the.
You want to we can check the vHub.
Yes, the vHub.
Let me go back. I'll just go back to. So I'll go back to. Yeah, I'll show that routing intent is enabled on the vHub, and I'll show where we do that. Probably should have had another tab for that, but we'll do it quickly. Show you guys some of my hubs. Simple, like I said, right? We have 2 hubs that are secured. For our tests, the one in purpose is the West US 2 hub. And to Nahali's point, you'll see here, if we go to the routing intent blade, we have it turned on for both internet bound and private traffic, right? And then obviously we're just using Azure Firewall, but if we're using another NVA, obviously the dropdown in there would be the NVA. And today we're just securing private, but the customer wanted to secure any additional prefixes, they could always put those in the private prefix box. And then also obviously to show, since I'm on here, this is where express route circuit's connected, right? As I mentioned earlier, we're still using the Megaport as a provider. So pretty simple. There's not too much more than that. Like, I could get in the routing tables and stuff, but for this purpose of this lab, we probably don't really need to show that. But if you were to look at the routing table, the default route table would just show the RFC 1918 as well. Since we have routing intent turned on, that takes over the default route table. So I think, Holly, at that point, we can probably just kind of go through the simple connectivity test, right? So
maybe we just grab the URL, show where the URL we are testing it is under the container, and how we have created that.
Right, good call out, Holly. So let's go back to our container here. And we created this this test PE container, Holly and I, and then inside that test PE container, we just have this simple HTML file. And then we're basically testing to this blob.core.windows.net/testpe, which is our container, and then the test file, which is basically just a hello world. So that's what we'll be doing our curl calls to verify that the traffic for the private network policies. So pretty simple. So first test, let me just make sure obviously that we have connectivity with GCP. So I kind of already have SSH into this, but we're going to ping the Azure VM from GCP. So 10.3.0.4. We can see that that's working. So we have end-to-end connectivity. Now, I believe if we try to do our curl test now, I think that should be turned off. I can't remember, but we'll just see what happens here. I think it's turned off, but let me just bring it in here. It's actually working, so let me go ahead and disable that. It shouldn't be working, so we'll kind of switch gears and pivot. Let me go and actually turn it off, and we should see that it's not working. So let me go back to our subnet here. Sorry guys for the switch up. Where's my spoke VM? Okay, let's go back to really quick here. I'm gonna kind of go back a couple of places. So I want to turn this off and show you that with the policy is disabled that it doesn't work, right? So let's go to our spoke VNet, let's go to our subnets. We're going to go to our private endpoint subnet, and let's actually just take these two off. Sorry about that. I'll give this a second, and then when we do the test again, we should see that it fails. So we'll wait for this to be disabled. Looks like it's already disabled, no, still running. And then we try our curl test again, and we should see that it fails, right? Because we're not enabling the policy. So let me go back to GCP, and let's run this again. And it fails, so this is the default behavior. So sorry, like I said, it did a little bit of 180. This is the default behavior, so we don't.
So that's
we don't.
the asymmetric routing.
Correct,
That's the
correct.
asymmetric
Yeah.
routing issue that we saw earlier, right? In the
correct. So this is the default behavior, as Nahali said. This is the asymmetric routing where you're not using it. This is what it will do. It'll fail where it will hit, but then the return traffic goes to the firewall, which obviously breaks the flow. So this shows that it's actually not working. So I kind of skipped ahead. I ran test 2 instead of test 1, but that's okay. So, now that we've, shown that it's working, once you turn on and turn it off, we can I'll kind of go to the second one again, but just for intents and purposes, let's go back. So go back to, let's go minimize this again. Do I have the tab open? I thought I did. Okay, let's go back to here again. So now that you guys have seen that we've disabled it, right? So now let's go ahead and turn it on again. So now we'll just kind of do the second test, which would be the correct order. We're just going to enable it now only for the route tables, because this is the setting that you need for the route tables for the /32 to show that it's working. So I'll just do this test again to show you guys cleanly. And then after this, we can move to some other tests and talk about DNS as well. So I wanted to talk about DNS, but after we run this test one more time. So now that we've done this, we should see that it's working. So this is what you'd have to do to not get the asymmetric. And you can see now that we've got the body back from the curl command, which is good, right? So one other thing I wanted to show you guys is the DNS settings on the Google VM. And in reality here, you wouldn't want to change the host file. You'd want to use a proper DNS method like custom DNS servers in the VNet, or you want to use private resolver. For this test, though, we're just simply doing just the host file. So yeah, that's what I meant to show. Okay, and we can see here that we just added the static entry, right, to make the DNS resolution work. We're more concerned about just the network, but like I said, you wouldn't really want to use this, but for testing Windows and Linux, this is fine. So we just manually added the host entry for this test. So I think the first test, we pretty much covered that, Holly, right? Even though I did it backwards, we showed that if you don't have it, you have the asymmetric behavior. If you enable it on the routing, it works, right?
So should we look at the firewall logs just real quick to see that it is indeed hitting our firewall?
Yes, and I thought I had that tab open, but let's just duplicate another tab. Oops, sorry, wrong ID. Yeah, we'll check the firewall logs. And I'm just going to use the simple canned rule.
The source IP. Yeah, that would be just well, right?
Yeah. Why is this not pasting here? Come on. And it's about 2:50 here PST, so it's probably this one here 3 minutes ago. We can see that that was allowed, right, from our source, which is GCP, going to the destination, right, which is the private endpoint over 443, and we can see that that was allowed, right? So pretty
Yeah, and I'm
basic. Yeah.
wondering, should we do the deny test now or later? So if we deny it on the firewall, this would
Oh,
again
yeah.
stop working.
Good point, Holly. Yeah, let's just change the can rule, the easy can rule.
Mm-hmm.
So we'll change that really quick to too many blades. Okay, policy. Yeah, so again, to Nahali's point, you never want to do this. I'm just lazy, kind of just for the simple lab. I left a wide open rule, but in reality, you'd want to make that way more finely grained. But for the simple rule test, we're just, we just did any allow, but let's go ahead and change that to deny and then try the test again. You should see that it's blocked. So let me go ahead and deny that. And we can check the firewall rules after that again too. I should say the firewall logs. Okay, so it looks like the rule got updated now that finished. And just to verify, if we see here, you can see that should have got changed to allow. We'll test. So if we go back to our GCP VM, we can check the firewall rules too. But I should be able to curl now.
No, we changed it to deny, right?
Or
So we
deny, to
expect,
deny.
yeah, yeah.
Correct. So we
Yeah.
changed, yes, Holly, yes, we changed it to deny. So yes, it's been denied, correct, from
And
allow.
then we can double check in the logs that it hits the
Yes,
deny rule though.
right. So let's go back to the logs. And we should be able to run the same one. Let's change this 30 minutes. And may have not populated quite yet. Sometimes it takes the ingestion times a few minutes.
Mm-hmm.
Make it run maybe a couple more just to generate more traffic just in case. Let's just go. Yeah, I think it's like sometimes it's like a 2 or 3 minute ingestion for Custo. So let's see. Let's run this again. Okay, looks like maybe we got a little bit more data, and yeah, there we go. Now we have our denies, right? So the same thing from GCP to our PE, and then denies, right? And that was as of like 1 minute ago, right? So much according to my time. So yeah, this is accurate. So we see that it got denied now. It's 1 minute ago. So yeah, so the purpose of that was to show that obviously you can change your behavior within Azure Firewall, right? Pretty simple. So really, those are kind of the first two tests. We toggled the policy on and off for routing. We tried we disabled the firewall. We showed that was blocked. We showed the going through the firewall when it wasn't blocked and blocked. So really, the only last test that we wanted to show today is that you can also do this at the NSG level. So before I do that, let me go and I should probably change the rule back to allow. And then what we can do is we'll create an NSG and we'll deny that. We'll see that that should still work. But then once we change the policy to NSG, it should show that it's blocked. So let's go back and change the policy back to allow again here. I didn't need to do that, but just change this back to behavior that it was on. So try to take a couple minutes again. Hopefully not as long as last time. We'll see if it's a little bit quicker. And then maybe while I'm waiting for that, now we'll create the NSG, right? So
Mm-hmm.
while we're waiting for that, so let's go to, I don't know, okay, I thought I had a VM tab open. Okay, good. So if I go to no, just gonna type in here, let's just do it here. Okay, so we don't have any, we're just using the default rules. So let's go ahead and add our deny. So we'll do source star any, and then we'll just do to our PE, which is 10.3.1.4. We don't want to do 8080, we want to do star. Just leave that as custom. We'll just leave the rest default. We'll just go to add. Okay, did that one finish? I think the other one should have finished. Now we should see that this is still allowed, right? Because we didn't change the policy yet. So if we do the same, we just bring a new line just for sanity. If we do the same command, yeah, it should still be allowed, which is by design. Just want it one more time just in case. Okay, it's still allowed. Now, let's go and update the policy for NSG. And we technically, Holly and I have one other test to show. We'll kind of do combo. Let's go back to the VM. Probably should have just kept it open. So let's go back to our subnets. Now we're going to change it to NSG, and we should show that it's blocked. Change the policy, like I said, to that, just to NSG for now, and then we'll do route tables too. So let's just save.
And that NSG tab that you have open, Adam, the one over there,
Yeah, right
that
here.
one is associated to the PE subnet, right? The one.
Right. Yeah,
Okay.
to the PE
PE
subnet.
And now you have the inbound rule as allowed or deny. I forget what we set it to. Is it?
Changed it to deny, or I thought I changed it to deny.
Yes, I think we should make that deny.
Yes, good point. I thought I changed it to deny.
And it would
Should still allow technically, right? Yeah.
No, because you toggled it, right? Did we toggled it, right? So it will not work.
Oh, we could, yeah, correct. I'm getting ahead of myself now. Since we toggled the policy, correct, it's blocking by default, correct, because we changed the network policy. Now, however, if we put the deny here and we didn't change the network, if we left the network policy off, it would still allow, but yeah.
Yeah, so let's do that. I think that's a good test. So let's go ahead and toggle the NSG on the other end.
Right, so even though it's denied here, if we go back to our spoke.
It's not at play. It will not be at play. So that's the key. See, first time I did it, I was
right.
Trying to understand this behavior, but right now that NSG is not at play.
It's not in play because the PE is still more takes priority, correct? So yeah.
Yes.
So now we go back and do our test. It should work. Should work.
Yeah.
Might take a second to take effect. Why is it not working? Make sure I didn't goof anything, right? So let's double check on my work here.
Double check the NSG there.
So it's disabled.
Oh, is it going? Yeah, so the route table is off. Everything is off, right? Okay, right. So if the route table is off, it's going to get asymmetric.
Asymmetric again. So technically, this needs to be still enabled, right?
Yeah. Yes.
Yeah, I got ahead of myself again. You have to have the route tables on at least, or we get back to our first scenario where it won't. So, but even though we have the route tables enabled and we have the NSG enabled, now it should work. It shouldn't be asymmetric, but it won't be blocking. Yeah, so it works now. So, but if we turn the NSG
now it goes through the firewall as well as it's allowed. No, now it just goes through the firewall. That's it, right? And then we need to do if we do the NSG.
Correct. So now we do what I had originally. So now if we go back and we just do the NSG, then it should be then it should be blocked. Or if you leave them both on, let's see this behavior. So if I'm trying to think, so if we have the network security group on the route table, this should still, I think, work, right?
Your NSG is set to deny, or
Deny.
is it? Yeah, so it will not work, right? If it's not, it's set to deny, it will no longer work.
Yeah, so this should
Yeah.
not work. Yeah. So, which is what you want, because if you want to, if you want to have the NSG toggled, you basically, you want it to be denied, assuming that you have the correct NSG in place. So that makes sense. Yeah.
Yeah, and you have to steer everything through the firewall, because if we don't, then it fails, right? If there's no routing set
Right.
up,
Then we
it
hit our
fails.
first
That's your
scenario.
first scenario. Yeah, exactly. Awesome.
Yeah, I think that's it. Sorry, I had skipped ahead in a couple steps and ran step 2 instead of the
Oh, all
second test
good.
instead of the first test, but essentially to cover those 3 things. Yeah, the first scenario was the asymmetric with no routes enabled. Check the firewall rules, disabled it to the firewall. Second scenario, we toggled the firewall on, and then we also checked, like Nahali mentioned, with the NSGs, toggling that on and off. So pretty basic, but as you guys can see, it makes a big difference. The traffic flow, whether you enable the network policies or not. So that's why we tell folks that you need to enable that, right? Otherwise, the /32 is more specific and it'll bypass the firewall. So I think that's it. No, I don't know if there's anything else I can really show. With this simple connectivity test, like we could definitely possibly expand on some further scenarios, but that was it for today on the simple test. So.
Yeah, only other thing, maybe for a future video, maybe we give a glimpse of it, is if you go to the vHub and the firewall policy, you had opened somewhere where you had the network rule.
Right, so let's go back to, you're talking about the routing intent?
The network, the firewall manager in the network where you had the any rule.
Oh, inside the firewall policy, correct.
Yeah.
Yeah. Yep.
So I think I showed this in the draw.io, but if you click on the rule, if you want to, let's say if you want to edit the rule, actually we'll have to go through the rule collection, right? If you go through the rule collection, maybe, and edit, what I wanted to show you was that in the destination type, we have IP address, right? So if this was FQDN, then we would have to set up the DNS correctly so that the firewall can resolve the DNS. Or if this was an application rule, so instead of a network rule, if we had application rule, we could also do FQDN based rules.
Right. Yeah, for these simple intent purposes, we just did network only, but great point, Nahal. Yeah, we'd have to configure it for FQDN, and if we wanted to do that inside network rules, it'd be a little bit more complex. Yeah, because we'd have to do the DNS proxy. Good
So
call.
let's go look at the DNS proxy while you are here. So on the left-hand side, in the left navigation pane, if you click on, so here, if you clicked enabled,
right.
And this is more for on-prem, you can hit custom and put like a IaaS-based DNS server, or like Adam mentioned, we could do the PaaS-based resolver, right? The DNS resolver IP over here. And the firewall also acts as a DNS proxy. At the bottom, you can set it up as a DNS proxy, because you would have routing from on-prem to the firewall internal IP. So that's the setting. And then there's one more setting, maybe for the completeness of the video, the default setting for SNAT. You can just show that.
Yeah.
That by default we are using sort of no SNAT for RFC 1918, right? It says are
Right.
exempt, are except those. So those
Mm-hmm.
are,
Mm-hmm.
yeah, good stuff. And if you go to application rules on the left,
Mm-hmm.
we didn't do this today, but for with application rules as well, you would need
Add a rule collection, add a rules. Yeah.
FQDN based rule. You could do FQDN based rules, but the good thing about the application rule is it doesn't do the SNATing, right? Like it
That's
does the
netting.
SNATing, sorry,
Yeah.
by
That
default. Yeah.
that does do that by default, correct?
Yes.
Yeah. Yeah.
Good stuff. I think we covered all of the screen captures that we wanted to capture our lab as well, Adam. Great demo. Thank you.
Yeah,
Anything
appreciate it.
else? Anything else you want to call out before the session?
No, I think
Yeah, one
that's
other thing, appreciate that, Nahali, that I forgot to mention, I probably should have shown it at the beginning is when I showed earlier the effective routes of the VM, right? When you guys saw that the VM only learns obviously the RFC 1918 when you turn on routing intent. But what I wanted to show you guys is that we have this feature now. It's been GA for a little bit while, but if you go back into our secured vHub, in this case, this is our secured vHub, you can actually still see the specific routes that you're learning, right? From our case, from our branch. So if we go to this effective routes here, as you guys, I'll wait for this blade to populate, but you can see here it's kind of an Azure Firewall in gray. But it's pretty neat because if and they're working on this, for other NVAs as well. But I wanted to show you guys this really quick is that because some customers don't know this, that's kind of hidden in here. If you choose, your firewall resource, you'll still be able to see the specific routes that you're learning, which is helpful, right, for troubleshooting purposes and stuff. And as you guys can see, we're not seeing the RFC 1918 in here, right, like we saw in the VM. We're still seeing the specific prefixes that we're learning over GCP as evidenced by the 12076, our MSE ASN, the 133937, which is our megaport, and of course our GCP ASN. So nothing super fancy, just a kind of, like I said, another tool in your tool belt to see specific routes that you're learning, as opposed to this view, as I'll show you guys, if you were just to check the default route table, which obviously here you're just going to see the boring RFC 1918. So it's kind of neat because even though you're doing routing intent with secured hub, we can still see the specific prefixes that you're learning, right? Which is kind of a big difference as opposed to just this view, right? Which is just next hop firewall. So
And did you say,
yeah.
Adam, that that view is only available for Azure Firewall?
Yeah, I think today, technically, if you have another NVA flavor, there was an issue where it wasn't populating correctly. So I think today it only works 100% with Azure Firewall. They are working on fixing that behavior with some other providers and other vendors, but yes, today, as far as I know, it still only works with the Azure Firewall solution.
So when we do our
So,
session with John and Checkpoint, maybe we could double check this. But
right.
good stuff, Adam. Thank you for showing this. Anything else?
No, that was just the last fun little thing I should have shown at the beginning, like I said, when we showed the VM effective route. So I think that's all for me, Nolly. Appreciate it.
Excellent. Thanks everyone for joining. I hope you enjoyed the session and thank you, Adam, for the demo. And we will see you in the next video.